Thank you for the invitation to attend and present here. I'm sorry I can't do it in person as I had a prior commitment to another trip, but it's a pleasure to be here. I want to talk about the needs for modeling to address the antimicrobial resistance impact of azithromycin mass drug administration. And my argument, I think, is going to be that while we could use modeling in principle, there are a lot of empirical and epidemiological questions that we need to address before we're going to be in a position to use models in a meaningful way. Although the needs for work in this area include preparatory modeling as well. In order to model these impacts, I think we need to follow about 7 steps, which I will go through in the remainder of this talk. The first point would be to try to estimate the impact of a single round of mass azithromycin treatment on the prevalence of resistance in various bacteria and how this changes over time. This has been done nicely for Streptococcus pneumoniae, as shown in a single study in multiple sites on the left, and on the right in a recent review of multiple studies. You can see a lot of variation even within the same study and certainly between studies, and so understanding the sources of these variations will be essential to doing a more comprehensive modeling approach. But we'd also really like to know not only what happens with one treatment, but with multiple treatments. And in fact, on the left-hand side, you see the multiple treatments every 6 months in the study being presented there. And on the right, you see that there were multiple treatments in many of these communities. And some of the variation is probably due to how many treatments there were in a given place before they started measuring. So we'd like to know ultimately what is the impact of a long-term policy on the prevalence of resistance in these bacteria, or sort of what is the new equilibrium in the setting of routine mass drug administration to a particular part of the population. And to answer that, we need better models, and this we can do now, we don't have to wait for the other data, to understand how it is that antimicrobial treatment affects the prevalence or the rate of change in prevalence of resistant and susceptible bacteria. This is a point of much controversy. A number of us have been working on this, both in my group, in Oxford, in other places, and at the London School in the lower right-hand side. There are competing models that try to address this, and I don't think we can really move much forward on this or most other questions about antimicrobial use and resistance until we have a better empirically informed understanding of which of these types of relationships is the most important and how that varies by pathogen, because I don't think it's going to be the same in all pathogens. Antimicrobial use is clearly a major factor influencing the proportion of resistance. This is a landscape analysis we did recently of the state level within the United States variation in resistance to various antimicrobial agents in various bacteria as a function of antimicrobial use. So it's a correlation between use and resistance. And you can see that there is a correlation for most of them that's positive, sometimes statistically positive and sometimes just positive. But that correlation is never perfect. And it's often quite limited, and so that tells us that there are other factors besides the use of a single drug class that influence the prevalence of resistance, and that is really just beginning to be understood. We need to move beyond strep pneumoniae, which has been perhaps the best studied off-target effect of azithromycin, and understand which other bacteria are also targets or off-target effects of azithromycin in terms of creating resistance or promoting resistance. This is an effort to understand in the United States the extent of off-target effects of antibiotic treatment, or what we call bystander selection, where the right-hand side is the proportion of all selection that we estimate occurs for antibiotic resistance in a species that is not attributable to an infection it causes. So almost all of the selection experienced by all of these bacteria, except for Strep pyogenes, is due to off-target effects of treating something else, whether that treatment be appropriate or inappropriate. What we'd also like to do next is to estimate the change in incidence of drug-resistant, including multi-drug-resistant infections that result from an MDA policy. The problem here is that we don't have good incidence data for most places in the world, even of specific syndromes, much less of the incidence of specific etiologies or drug resistance. And this, as is often the case, is a bigger data gap in places where the intervention might be the most promising. Crucial here is the next step, which is to estimate the number of treatment failures that would occur when drugs are used to treat these resistant infections that might occur due to mass drug administration. And this is challenging because the rates of treatment failure for resistant infection are not clearly discernible as being different from susceptible infections in many studies. Shown here is an example, an excerpt from a Spanish study of macrolide-resistant Streptococcus pneumoniae pneumonia, and there's no effect shown of resistance on any bad outcome. And while this may not be the situation in all cases, and certainly we should be concerned about drug resistance, I want to emphasize that we're not interested in drug resistance as a bad thing in itself. We're interested in it because it leads to treatment failure and greater bad outcomes. So, for example, a corollary then is that resistance to a drug that is not used for treatment is not important. And that is the case for the drugs being considered for macrolides in many of the places where mass drug administration is being considered. We also would want to estimate more exotic effects like the promotion of reservoir of mobile resistance genes, effects on the microbiome, etc. I think those are more remote, but others would see them as more crucial to understand, and that's mostly not understood at the moment. And then we'd want to weigh all of these effects against the measured mortality benefits. I think it's worth pointing out that we experience a certain psychological tension because we're all trained to oppose antimicrobial use on a sort of precautionary principle, especially in settings where there's no clear bacterial etiology causing the syndrome that we're trying to treat. So this is exactly the kind of use, mass drug administration, that we're trained not to like. But on the other hand, we have now a randomized trial that suggests that there's a mortality benefit, and that's not usually the case. We usually think of unnecessary use or non-targeted use as inappropriate. But now we have an actual indication, although it's one that's not fully understood. It's certainly worth considering the possibility that whatever benefit for mortality we see from mass drug administration at the moment would decrease as resistance increases in some of the pathogens that cause the syndromes that lead to the preventable mortality. So if resistance increases, as we would expect it would in response to MDA, the mortality benefit might decline, and I think trying to quantify that would also be essential. So those are the steps, and I had hoped to put some green here for something we really understand, but we're mostly in the sort of in-between orange or we don't really have much data area of red, and I think there's a lot more to be done. In terms of prioritizing what should be done, I think we need studies of the relationship between the use of antibiotics and the resistance to antibiotics in many different species, trying to understand whether it's an effect on the level of resistance or the rate of change of that level. That's a modeling project, as many people at the London School and in our group and elsewhere are interested in. It's also an empirical question. We need a better understanding of the relationship between resistance and treatment failure in various settings, and understand why it is that sometimes, even when treated with a particular drug, resistance does not lead to greater treatment failure. We need a lot more data on the incidence of specific syndromes and the etiologic agents that cause those syndromes. And then I think we may be able to do some heuristic work to put some bounds on the effects of mass drug administration, even if we can't estimate them well. And first, if a drug is not used for treatment, then the burden of resistance to it will be small, meaning even if there's a lot of resistance, the impact on health would be modest or non-existent. And I think it's also worth trying to make some comparisons between the amount of azithromycin use community-wide that's being envisaged in various MDA programs and the rather dramatic amount of antibiotics that are used in wealthy countries in the same age groups, which may be comparable or nearly comparable to the amount that's being envisioned, and trying to understand how those wealthy countries have experienced consistent wide-scale use of antimicrobials should probably give us some context for understanding the effects in places where MDA is considered. I'll stop there and thank my collaborators and partners in conversation about this interesting topic. Thank you.